Okay, so today's topic is moment of inertia. So what is moment of inertia? First, let me understand what will be the meaning of moment of inertia. Then we'll solve how to solve questions of moment of inertia, like how to solve them. Okay, so if you try to push a body, suppose I try to push a body and I apply a force F, then the acceleration of this body will depend on its mass, because more the mass, more will be the inertia. So for translation motion, suppose I want to move a body, so for translation motion the inertia only depends on mass. But suppose that this is an axis and this is a road and a mass m is attached like this. Suppose I want to rotate this. So for rotation, the mass is also important and the distance is also important. So for rotational motion, so for rotational motion, the inertia depends on both. Both means the value of mass and the distance of mass from the axis. So the perpendicular distance from axis is also important. So for translation motion, the inertia is only depending on mass, while for rotational motion, the inertia is depending on mass as well as the distance of the mass from the axis, that is r. So how to calculate moment of inertia? So let's understand how to calculate moment of inertia. Suppose there is an axis and a mass m is at a distance r from the axis. So the moment of inertia of this mass about this axis will be mr square. So moment of inertia is basically mass into square of the distance of the mass from the axis. Suppose I have axis like this, and suppose one mass is here m1 at distance r1. Suppose another mass is here m2 at distance r2. So the total moment of inertia will be the mass m1 is at a distance r1, so m1 r1 square. The mass m2 is at a distance r2, so m2 r2 square. So this is how we calculate moment of inertia. So moment of inertia only depends on two things: what is the value of mass and how much is the perpendicular distance of the mass from the axis of rotation. So moment of inertia depends on only these two factors. Suppose, let's solve one more question. Suppose we have axis like this. Suppose one mass m1 is here, one mass m2 is here, another mass m3 is here. And suppose the distance of m2 is r2, distance of m3 is r3, and m1 is on the axis. So what will be the total moment of inertia? Since m1 is on the axis, so m1 into square of 0, because r is basically distance of mass from the axis. So if mass is lying on the axis, then the distance will be 0. For m2, the inertia will be m2r2 square. For m3, the inertia will be m3r3 square. So this is how we calculate moment of inertia. So for all the masses, we will calculate inertia separately and then we'll add all of them. Okay, now let's take some important bodies for which you have to remember the moment of inertia. Suppose we have a road. Suppose we have a road of mass m and length l. So total length is l, mass is m. So moment of inertia about this axis will be ml square by 12. So if the axis is passing through the center of the mass, then the moment of inertia will be ml square by 12. And suppose the axis is passing through the side of the road, same mass length L, then moment of inertia will be ml square by 3. So please remember, if the axis is passing through the center, then inertia will be ml square by 12. And if the axis is passing to the side, then inertia will be ml square by 3. Similarly, for solid sphere, suppose we have a solid sphere and the mass is m and the radius is r. So about this axis, the moment of inertia will be 2 by 5 mr square. And similarly, suppose we have one hollow sphere. Suppose we have a sphere which is hollow in nature, same mass radius r, then the moment of inertia will be 2 by 3 mr square. And both the axes are passing through its center. So the axis can be anyone. So about this axis also, the same inertia will be there. About this axis also, inertia will be same. The axis must pass through the center. Similarly, suppose we have a disk. Suppose we have a disk So if the axis is perpendicular to the disk and passing through center, then the moment of inertia will be mr square by 2. So m is the mass, r is radius of disk. And suppose the axis is passing through center, but the axis is in the plane of the disk, then about this axis the moment of inertia will be mr square by 4. So suppose I ask about this axis, what will be the moment of inertia? So it will be mr square by 4. And suppose the axis is perpendicular and passing through the center of the disk, then mr square by 2. So you have to remember both this moment of inertia. So any axis passing through the center of the disk and in the plane of the disk, the moment of inertia will be same, that is mr square by 4. That will be mr square by 4. So if the axis is perpendicular, then mr square by 2. If it is in the plane of the disk, then mr square by 4. Similarly, we have ring. So for ring also you have to remember, suppose we have a ring and some axis is passing through the center of the ring. So about this axis, the moment of inertia will be mr square, where m is mass, r is radius. And suppose the axis is in the plane of the ring. So about this axis, the inertia will be mr square by 2. So in the given figure, you can understand this. So about this axis, the moment of inertia will be mr square, but about this axis, it will be mr square by 2. So if the axis is in the plane of the ring, then the inertia is mr square by 2. But if the axis is perpendicular to the plane of the ring, the inertia will be mr square. So suppose there is one more axis which is in the plane of the ring. So about this also the moment of inertia will be mr square by 2. So if the axis is perpendicular, then mr square. But if in the plane of the ring, then mr square by 2. And lastly, we have one hollow cylinder and one solid cylinder. So remember, if the axis is passing through the center of the hollow cylinder, then moment of inertia will be mr square. But if the cylinder is solid in nature, then the moment of inertia will be mr square by 2. So this is how you have to calculate moment of inertia and remember moment of inertia of different bodies. Like, I'll solve some questions now. Suppose that we have this axis and we have a road here of mass m, length L, and there is another mass m at the end of the road. So my question is, what will be the moment of inertia about this axis? So we have two mass. One is road and the axis is passing through the side of the road. So the moment of inertia of road will be ml square by 3 plus there is a mass m which is at a distance L from the axis. So moment of inertia will be ml square. So this is how we can calculate moment of inertia. So the moment of inertia for different masses will be same. You have to calculate the individual MOI and then add all of them. Okay, suppose I take one more example now. Suppose I take like we have a solid sphere here and we have one mass small m here, one mass small m here, one mass small m here, and another mass small m here. And the mass of the sphere is also m, but the radius is r. Now my question is, what will be the total moment of inertia? Now there are five masses. Since the axis is passing through the center of the solid sphere, so inertia for a sphere will be 2 by 5 mr square. Now for this mass, it is on the axis only, so inertia will be 0. For the below mass also the inertia will be 0. This mass is at a distance r from the axis, so inertia will be mr square. And this mass is also at a distance r from the axis, so inertia will be mr square. So you have to add all of them to calculate the total moment of inertia. So this is how you have to calculate moment of inertia. Okay, so moment of inertia is a very important topic. You have to individually calculate the moment of inertia, then add all of them. Okay.